Welcome back. It is day 110 of daily LeetCode. Today's video will be called "The Beginning is the End and the End is the Beginning." I don't know what that means, but we're back once again. I was actually supposed to start LeetCode a few hours ago, but I got just lost in the Saucington. But nonetheless, we're gonna do the weekly challenge today. But I just wanted to think for a second. Yeah, I was able to do something recently. I guess what I was gonna say is there's just really there's nothing like doing something for someone else, I think. And yeah, I think I always talk really general and ominous, and really there's a lot of space for interpretation. But maybe that's the whole point of talking a certain way. You're right. In a good film or a good song or a good movie or a good book, there has to be enough space to find your own human experience or human condition in the story. I think a lot of times when there's not enough space in the medium or whatever the vehicle is to tell the story, there's not enough space to see yourself in it. It just feels a little cramped, or it feels like there's a message being forced down your throat. But sometimes the thing that you're looking for, sometimes the message you need to hear is a message only you can find for yourself. Maybe that's why stories or movies or music that has space for someone else, all those different mediums have space for you to write your own signature on top of it. And I don't really know what to wrap all that back around. I guess what I'm trying to say is I talk really ominously. That's just because I try to stay a little bit private. I'm not really certain why I'm involuntarily private. But anyways, they say that the human love is so powerful that when it's told in the right way, or when you can experience it, or when it's told or story told or heard or seen, just the sheer magnitude of it, when it's told correctly, is just overwhelming. And I guess all that to say, I got to do something really cool recently, and yeah, it was just really awesome to see just the way that things kind of come and go. Something comes a certain way and then comes full circle. So I got to do something really cool for someone pretty close to me recently. So it was just interesting to see that there just isn't something like doing something for someone else. And maybe we're supposed to be that way, maybe because we're really just some apes and we have to go back to monkey. And maybe we need to have those emotions or that thought process or some innate genetic predisposition or firmware, maybe some software, to feel that way about doing something for other people. And maybe that's, how we've gotten so far, but who knows? All that to say, we have some cool projects in the pipeline, and yeah, I have some ideas about some things I want to work on. Today is going to be the day that I start working on some of them. But besides that, I've been doing some thinking. I think we have to restructure the learning. There's an issue back in the day, yesterday, and I have to save some content because I have to talk every day, right? So I have to save some content so I won't fill in all the bubbles here. But in another life, I used to do a lot of artisanal lines on paper. You look at the lines, you feel a certain way. And I think if you scroll down in the channel far enough, you'll find a few of those videos. That being said, I learned a couple things about myself when I was on that drawing journey, and that I tend to become pretty much sucked into the art of like getting better or working or focusing on something. For example, I think there are people who create art and their whole not purpose, or it's not really relevant, but they create art and they may not be the best technically, but they can evoke an emotion in others with what they do. And I came at it from a completely opposite point of view. There was a technical or functional aspect of putting lines on paper that I thought was computationally intensive, and I wanted to be someone who was capable of doing that. And yeah, I just became enamored with being able to be someone who could do that. And one of those people who I thought was really good at it was Kim Jong-gi, legendary artiste. But all that to say, what I learned was that oftentimes I'm more interested in running the treadmill of progression than actually creating something. And to tie it into LeetCode and especially the art story, I was more interested in becoming good at drawing than I was good at being able to, compose a 3D space on a 2-dimensional surface than actually being able to create something that was saying anything. And it's definitely a crossroads, or it definitely feels like something like that. And I find, some essence or some seeds of that, especially in the LeetCode. I do a lot of LeetCode, and part of it is flexing that mechanical part of, reframing a problem or always coming into difficulty with something that's challenging you, which is important. But another part of it is just like, okay, but what about the end? What comes after that? Right? Presumably, one wouldn't just be wanting to do all these problems for the sake of doing all the problems. So, yeah, I do have things I want to make, and I have to just be wary. I think it's always a balance. I think we're all going to have some like thought traps to fall into. It. One of my thought traps seems to be getting lost on the progression treadmill. And I love me a good progression treadmill. And I think that's precisely why I always play games like... I personally can't play a game unless there's ranked in it, because I need that progression. I need to know that I was better today than I was the day before. Whether that's good or bad is a mixed bag, but it certainly has done me well in certain aspects and poorly in other aspects. Sometimes I'm too concerned with metrics. All of that to say, coming full circle, the idea, what's going on here, is that my method of structuring learning is a little bit messy, right? Because I'm learning all these things, but one has to ask, to what end? Right? To what end? And I think to some degree, you need both of these aspects. You have to want to say at least a little something, but you also have to be interested in getting better at whatever the functional aspect, which is pretty interpretive of the task at hand. And I think I got lost in the sauce with programming, and I've just been learning a lot of things to hopefully make something in the future easier. And I think in the midst of all that, I forgot the reason why I started, not the reason why I started, but one of the greatest benefits of doing something every day was becoming comfortable with exposing oneself to resistance or challenge. And yeah, I think after a while, I've become accustomed to the challenge of daily LeetCode. I'm familiar with it. It's a devil I know, even though it's not the best all the time. That being the case, I think in another sense, it's also comfort. So all this to say, the other discomfort that I'm avoiding is just making something. And the reason I went from LeetCode, one reason that LeetCode is really good, and just anything that actually enforces application, is that it's a really good encoder for memory and skill. And another way to learn is also by doing. And so I think all of this stuff that I've been doing so far, because I usually do like blocks of learning like 3 to 4 hours, is really good. But I think the last few days I've only been doing the LeetCode. I haven't been doing the other stuff. I've just been thinking. And I think there's always always a need for reflection. All that to say, I'm going to try and mix in some application by actually doing what I need to do. And I know that I've run into this problem before, which is funny because I don't have all the drawings behind me, but I used to do a lot of drawing and stuff like that. And on one of my pieces of paper, I wrote, learn in the context of a specific problem, then you will stop. You will naturally stop when you have solved the problem. And I think I fell into another trap because I remember why I wrote that. I was learning all these things about drawing, trying to learn everything so that drawing would be easier. But the learning is never ending. And yeah, I think another way to do it is to try and make something and then do like kind of a dendritic walk to the adjacent topics or things that are necessary for me to complete the task. What I'm saying, I guess, is that there is a need for both. Basically, I guess to put it in an analogy, I was someone who was anticipating, let's just say like a sprint or marathon in the future, and for those reasons, I was purposely training fitness every day, so distance, marathon, sprinting, and all these things, just to realize that I've been infinitely pushing back my marathon date. And so I think the goal would be to do both. We'd also train before, because you don't want to fall flat on your face, and always continuing to get better makes future tasks that you're not even, ready for helpful, or makes it easier to do them, but also to ground it in application so you're not infinitely procrastinating. All this to say, I've made a bunch of other stuff in the past. You even find some animation on this channel as well. So all that to say, I'm gonna get to work. And so yes, that is what we're going to do. And part of getting to work is working on LeetCode. So it is day 110, and we're going to be starting today with a comment from Botea Public, legendary YouTuber, by the way. Recently done a rebrand. Check them out. First of all, your opening was epic. Second of all, thanks. Stay tuned for Sunday 4 p.m. So 4 p.m., guys, you're going to want to go to Botea Public's. And lastly, at 25. Oh, yeah, in day 109. Would it be more effective to have ++ instead of +1? So whenever we're I think there's a couple ways to answer a question. Think about something like this. I haven't done a lot of. I've done a lot of programming, but I've done a lot of programming, but I don't have enough wisdom from programming. So I haven't done enough. I don't think I have enough wisdom to say which is better. But I guess I don't have enough learned experience, or basically what I'm trying to say is ++ and += I think a good question to ask is, what are we trying to be more effective at? And I think ++ and += is it's not a huge difference. And I'm sure there are people who are very opinionated on which one is better, but I've tried, since I'm using a couple different languages, and not every language supports ++, or sometimes languages have ++ variable, which is like pre-increment. I try to just stay with what is available in everything. And yeah, I guess there's a pattern where I try to make everything portable. So if ++ and += right, if one is available in one language and not another, I just completely delete the other one from my mind. I'll just only use what's available in all of them. But another thing to say is, if we're talking like space or runtime, I think, and I don't know for certain, but I don't know if this is a huge difference. But you could have ++, it might be more readable to some, but I always think += 1 is, I guess it's just preference. I usually just go for += 1, but I'll leave that to the language bigwigs to pontificate about. But true. I'm not too certain. And also we have the LeetCode challenge today, the weekly contest today. Let me see. We have maybe we don't. Oh no, yeah, we have the weekly contest today. And I just realized it's on Fridays, and I didn't realize that. So I think it just happened. It was on October 1, sponsored by Air Wallet. So, yeah, so that's what we're going to do. We're going to do the weekly contest, and then, yeah, looks like this one's relatively easy. Last time, top 5 max time was 10 minutes. This one looks like 6 or 7. So that's what we're going to do. We're going to do number of common factors to start. Maximum sum of an hourglass, minimum XOR. It looks like there's a lot of math in this one. So we'll see how far we get, but no promises. And then I think we're just going to jump into it, to be honest. So let us begin, and make sure to join the Hyperbolic Coding Chamber. It is a Discord that is rapidly growing, and there's tons of secret tips and tricks. There's even a secret command line argument that you can pass to any modern compiler, interpreter, or anything in between, and it's going to automatically spawn a GPT-3 instance that will automatically fill in the code that is remaining. So you're going to want to join the Discord for that secret command line argument, and also about the specifics about why this has been included in every modern compiler. So you're going to want to know about that, and it's only in the Discord, so you're going to want to join for that. And then we're just going to jump into it. So we have number of common factors. Given two positive integers, A, oh god, I don't know what a common factor is. Given two positive integers, A and B, return the number of common factors of A and B. An integer x is a common factor of A and B. Okay. Two positive integers, A and B, return the number of common factors of A and B. An integer x is a common factor of A and B if x divides both A and B. So A is equal to 12 and B is equal to 6. Common factors of 12 and 6 are 1, 2, 3, and 6. A is equal to 25 and B is equal to 30. One, two, three, 6. Okay, so I'm wondering if we can just iterate over both numbers, starting at, we'll iterate over, so we'll take the smallest of the two numbers, right? Now I'll write this down. We'll take the smallest of the two numbers, and this is a massive window. Make my window smaller. What if we take min of both numbers, right? Iterate starting at 0 up to including B. And then from there, we'll just check all the common factors, right? We'll just check with modulus if both are divisible and increment if so. And so let's see if that makes sense. If we take the minimum of both of these, it's 6. And so we're going to go from 1 up to and including 6. And we'll check how many they both share. So 1 mod 12 is 1. It both exists for 6. Both works for 2, and it also works for 3. 4, 5, and 6 don't give a remainder of 0 for both, so it doesn't work. And for this one, it looks like only 1 and 5 works for both. We'd go up to 25 though. So let's try that. So we'll say smallest is going to be equal to A comma B dot min, and then we're going to iterate starting from 0. So we're going to say, for some reason I can't delete spaces. Yeah, and our spacing is off. Like bad. It might be because of this ones we pushed up forward. When I push tab, nothing happens. Okay, and then we're just gonna say if A mod num equals 0 and A and B mod num equals 0, do CT plus equal 1. And I'm wondering if that would work. So let's try it. I said we'd start at 1. That's my bad. Okay, so we got the first one right. Let's try the remaining test cases. A only goes up to B, I think, so it's not the worst thing in the world. So yeah, the submission page is, there's a lot going on the submission page right now. This is actually harder to understand. So I'm clicking it. Beats 100%. Sorry, not enough acceptable submissions. So You know what? We'll take it. Even though the submission page is very strange now. But, yeah, I guess the number of operations we're doing is going to be linked to the minimum of A and B. And I guess if they're the same number, I guess we could say min of A or B, I guess, would be this time. Wait, do I have to click start contest? Oh, virtual con. Oh, okay, it's already solved then, because I already did it, I guess. Maximum sum of an hourglass. You're given an m by n integer matrix grid. Okay? We define an hourglass as a part of the matrix with the following form. Return the maximum sum of the elements of an hourglass. Note that an hourglass cannot be rotated and must be entirely contained within the matrix. So an hourglass is of the shape I. Cells shown above represent the hourglass with the maximum sum. Note that an hourglass cannot be rotated. So let's reread this again. You're given an m by n integer matrix grid. We define an hourglass as a part of the matrix with the following form: A, B, C, D, E, F, G. Return the maximum sum of the elements of an hourglass. Note that an hourglass cannot be rotated and must be entirely contained within the matrix. Grid is equal to 6213, 4215, 19. Okay, this is our input grid. We're looking for the maximum sum of the elements of an hourglass. The cells shown above represent the hourglass with the maximum sum. So it would be 621 plus 2 plus 928, which is equal to 30. There's not that many hourglasses in here, if you think about it. M is equal to grid, N is equal to grid sub I, and it looks like M is at minimum less than or equal to 3, greater than or equal to 3, and so is N, but N then be up to 150 character, 150 so we can have up to 3 rows and n columns, or I guess 3 columns and n rows. Okay, I don't think this one's too bad. I don't know if our runtime will be particularly good, but I think we could get a solution, a best effort solution. I think, what if we just defined did an m by n iteration, brute force, and just took the sum of all the hourglasses? Cannot be rotated, must be entirely contained within the matrix. So ideally we would go like this. We start at 6, right? And we'd have a check. Is valid hourglass index. And we'd say, okay, our current index exists. Does the next one exist? Does the next one exist? Does this one exist? This one, and this one. If it does, then take the sum. Is it the greatest sum we've seen so far? All right, then we go here. This one would give us 30, which is our best number so far. This one would give us 15, 17, 18, 19, plus 5 is 24. 4. The other one would be this one, which is clearly smaller. This one would give us 17, 17, 20, and then this would give us 28. Okay. So let's try it. You know, we did the last one in Ruby, so let's just do this one in TypeScript, and then we'll say, so why is the text so small? I wonder if it can even be seen. Is this even readable? You know what? So we'll say brute force m by n, right? And then we'll calculate hourglass sum. It says it's a medium, but it's questionable. We'll see though. So you want to do m by n, right? So we want to iterate over each row, right? And then in each row, we're going to iterate over all the columns. Okay, so to do that, we're just going to say row is equal to 0, row is less than grid dot length, row plus plus. And then we can duplicate this and change this to column. And then the length that we get, right, is actually going to be grid sub row dot length. And then we'll do col plus plus. And then we'll add another bracket. And then I'll have a max sum, which is going to start at, and what did they like us to return if there's no sum? It looks like we'll have at least, looks like we'll always have an answer because m and m is at minimum 3. So we can just set this equal to negative infinity. So we're going to be taking the max. So with negative infinity, we know we'll be safe. We'll return max, and then we'll say we need to know if something isn't our glass, and I think it would be easier to read if we put it into another function. Actually, we can just do some hourglass and put it together, and we'll pass in the row, which would be a number, and we'll just make this a R, and the C, which will also be a number, and the grid, which is going to be an array of arrays, an array of numbers, right? And we're going to return a number. And what we'll first do is check that the hourglass formation exists by making sure that all the actual indices exist, and TypeScript will let us do that pretty easily with grid sub C. Actually, there's a simpler way to do it. We can just store the positions as an array of tuples or an array of tuples of the offsets from the current position. And one way to do that, right, the current position is going to be 0, 0. The next one is going to be 1 over, so x is 1 over, it stays the same. The next one is going to be, right, x is 1 over from the start point, we add 1, right, we're going to add 2 and keep x the same and keep y the same. The next one is we're going to add 1, but add another 1, so we go down. So we 1, 1. And then we'll add 1 and actually go 2 down. and then we'll just go 2 down. So we'll do 0, 2, right, and then we go over 1 and down 2. Wait, I think we already did that. Over 1, down 2, over 1, down 2, then just down 2, and then over 2, down 2. Over 2 and down 2. We should have 1, 2, 3, 4, 5, 6, 7. 7 total positions. 1, 2, 3, 4, 5, 6, 7. And what we'll say is we're going to calculate the sum, which is going to be equal to 0 to start. And then what we're going to do is say x offset, y offset of positions. We're going to say if, right, first we have to validate the indice. If grid sub r plus x offset, right, and then we go to the second, we try to index the column. C plus y offset, then we're just going to return negative infinity, because there's no hourglass that exists here, so we don't want to actually count this as a value. Otherwise, what we're going to do is just do sum plus equal grid sub r plus x offset sub c plus y offset, and we'll return sum. And then I think we should just be able to do max is equal to the math dot max of max and sum hourglass row call grid. The variables exist. Grid. So let's check if the positions make sense. The first one would be 0, 0. It's passed in. One forward, same row. All right, we actually have to change this because the second one is actually the y. Second one is actually the y offset, which means we're actually swapped. I think if we want to go 1 to the right, we wouldn't update the row, we would update the column. And this is not really x and y, it's just the row offset and the y and the column offset. So we want to go 2 columns over the 2. This one we want to go 1 column down, which is we add 1, and we want to go 1 column over, so it's 1, 1. This time we want to go 1 row down, 2 over. So maybe it's the opposite. We want to go 2 down and 1 over. Then we go, want to get these 2, so those are just going to swap to 2, 0, and then we go 2 down and 2 over. Since I got 30 and 35, the expected answer was 30 and 35. So let's try it. Oh, or I guess return 0. Okay. Interesting. I guess we didn't really know what we should return. Or maybe not. Oh, no, yeah, it always exists. So yeah, we'll just do that, and then let's try. So it looks acceptable. It's interesting to see that it's a medium, though. Looks like there weren't enough solutions. I feel like I can't see the graphs or anything. Maybe they took them all out. Yeah, it looks like they took it all out. Or maybe you can now see execution. It says click here. There's no distribution. So, we'll take it. We'll take this one. This one is also medium. Given two positive integers, num1 and num2, find the integer x such that two positive integers, num1 and num2, find the integer x such that x has the same number of set bits as num2. Two positive integers, num1 and num2, find the integer x such that x has the same number of set bits as num2. And the value x or num1 is minimal. Number of set bits of an integer is the number of ones in its binary representation. So if num1 is equal to 3 and num2 is equal to 5, and we have to find integer x such that x has the same number of set bits as num2, which it does. This is a coincidence that the numbers are the same, because you could also have 15. No, you could also have 13, which would have 3 set bits. So the text gives set bits of an integer is a number of, so in this, and the value of x or num1 is minimal. I don't even know how to do XOR. The number of set bits of an integer is the number of ones in its binary representation. Binary representations of num1 and num2, 0, 1, 1 and 0, 1, 0, 1, respectively. Integer 3 has the same number of set bits as num. Oh yeah, that's true. Integer 3 has the same number of set bits as num2. Because wait. X has the same number of set bits as num2. Number of bits set here would be 2, wouldn't it? 4 and 1. And integer 3 also has 2 bits that are set, 2 and 1. And the value 3 XOR 3 is equal to 0. And 0, 0, 1 and a 1, 1, 0 respectively. The integer 3 has the same number of set bits as num2 and the value 3 XOR. One is less than or equal to num1. And num2 and 10 to the 9. This one in Ruby. Okay. I need to look up what an XOR operation looks like. Okay, it looks like the XOR operator is caret, and XOR means exclusive OR, so either or, but not both. So true or true is false, true and false is true, and false is false. So what we could do is break this problem into two sections because we're trying to minimize something. And I'm sure you can do them both at the same time. I don't know how to do that. Say X has the same number of set bits as num2. Value of X or num1 is minimal. Given two positive integers num1 and num2, find the integer X such that X has the same number of set bits as num2. Looks like we have to find this. So that is what we'll do. X has the same number of set bits as num2. X has the same number of set bits as num2. That's what we'll do first, and we'll call it this the X pool, which is going to be an empty array. And what we're going to do is just find numbers that have the same number of set bits as num2. That is a lot of numbers. We consider that's a lot of numbers. That is a lot of numbers. X has the same number of set bits as num2. X has the same number of set bits as num2. X has the same number of set bits as num2. How would we generate all those? It's the same number of set bits. We could just, okay, if considering with a 64-bit number, we could just count from 1 all the way up to 64, 2 to the 64 minus 1, and just count all the bits. Is there a pattern here? If we just count all the bits, the way you could count the bits is with Hamming weight. And we could write a function to do that. We'll say, well, n does not equal 0. And this would, the time complexity in this would be abysmal. I need to figure out how to set an automatic vimRC in this application. We'll say n is equal to n and n minus 1. Take the and of n and n minus 1. We'll do ham plus equal 1. And then we could just count the number of set bits for every number. And if we do that, we could count the number of set bits for all the numbers from 1 to num2. You know, and let's try that. Start from 1, going up to and including num. Actually, no, we have to go all the way up. And I'll say you know what, we'll just do 2 to the 64 because it's 10 to the 9, so we'll just do that. So just go over that range and we'll say that each do num, and we're going to say if the ham of num, right, and we'll just pre-calculate the ham of 2. So if the ham of num is equal to num2 ham, right, then we'll say x pool dot push num. And then we're gonna puts x pool, see what we get, and let's just return 1. 1 is gonna be the wrong answer, but I just want to see. Okay, just going from 1 to 10 to the 9 is just crazy, it seems. I wonder if we can safely assume we can go up to num2. Maybe we can just assume we can go up to num2. It's an assumption we'll make. It looks like our answer is our x pool, you know, does actually include the expected answer, which is 3. And what if we use the example test cases? Three, 5, 6, 9, and it looks like okay. What if we just always return x pool sub 0? Okay, so it looks like we can't do that. So let's just say we'll just do min, right, which is going to, we're just going to start it at infinity, right, and then what we're going to do is going to return the min. We're going to say xpool.each do num, and now we want to take the minimum of that value XORed, right? So we'll say min is equal to min and well, it has to have the lowest XOR value. Value of x XOR num1 is minimal. It's like we need two things. I have the minimum num and the lowest XOR. And then what if we could say if the current number's XOR is lower than the lowest XOR, then it'll be the new minimum number. So if num Wait, value x. Oh, x or num1 is minimal. So say if num XOR num1 is less than lowest XOR. We'll say min num equals num. It looks like we can't actually stop at num2. So what if we stop at yeah, this is unfortunate. I'm actually not certain where we would start because we'd end up. If only we had a better way of generating all the numbers that had the same set bits. I'm sure there's some bit magic to this. It's the lowest XOR. What if there's a hint? Number of set bits of an integer is the number of ones in its binary representation. Turn the integer x, the test case to x. Given two positive integers num1 and num2, find the integer x such that x has the same number of set bits as num2 and value x or num1 is minimal. Test case. Let me see if we can figure out a pattern here. What if we just go from 1 to 100, we'll put x pool and return 1. It's going to be the wrong answer, but that's fine. I just want to know if there's a pattern here. Not x pool. That's not what we want to know. We'll do it like this. We'll push the number and the ham of the number. We're recalculating it. It's fine. I just need to know if there's a pattern. guess I would prefer that they're printed to each tuple. I think we use the ham of num. Wait. These are all the numbers with 2 bits. Set 3, 5, 6, 9, 10. Okay, I think there's a better way to generate all the numbers. There's a better way to generate all the numbers such that it wouldn't take this much time. So we could create another function. I'll delete these parameters here and I'll create some space. And then we can remove this. We'll keep this bit for the pattern. Keep the ham function because we need to know that. We're going to want to say generate find nums with bits, and then we'll pass in hamming weight. So expo is equal to find nums with bits of num2 sub ham, and we're going to have an R, which is empty to start, and then we're going to return this array. And then the spacing is off, by the way, but I don't really know how to fix that. Find nums with bits. Then I think we can just do, if we assume we're working with 64-bit integers, I think we can just do an n squared loop to generate all the possible n-bit variations. Maybe, for example, we have 6 bits, start at the first bit, generate all the bits. The only way I can think of it is as a graph problem. The time complexity on that would be crazy. want to generate all. I think we can come up with a version with 2 bits. When you take it to like 6 bits or something, how do you find the 6 different bits? Find nums with bits. Also, I'm returning an empty array here. Surely this couldn't work. I have an idea. If we go back to the original method, don't need this anymore. Keep the original method for now. Except the range would be different. We'd want num2, or because we want to find same number of set bits as num2. We'll set num2 as our end, and num num2 over 2 dot floor as our start. I'm not following what the issue is. Undefined method character for 3 2. Oh, I forgot. Yeah. So our answers, I think, are wrong. We get 3 and 6. Yeah, and the answer should have been 3 and 3. X has the same number of set bits as num2. I see. It's the smallest number you can make with 2 bits is 2. Yeah, even figuring out that doesn't make any sense. That does not make any sense. X or... Yeah, I wish there was a solution to this one. X has the same number of set bits as num2. Maybe tomorrow... Actually, I don't know if we'll stick with this one tomorrow. Maybe tomorrow, or... Yeah, maybe. We'll see. Maybe tomorrow we'll try a tree-based version. Try a tree-based algorithm. It doesn't really matter, though, because if you'd use a tree to generate all numbers that are x bits, you could have done the same thing by just visiting all the numbers from 0 to 10 to the 9. That's a lot of numbers. And maybe there's just less numbers if you do it by tree. No, we're just generating all numbers with 6 bits then. Yeah, I think it's the same number of operations, if not worse, because we're using space on the stack as well. Xpool ham, num2 ham. I think we're gonna have to call it. I hope. Yeah, I'm wondering if anyone else has any insight into this problem, or maybe we'll just keep it unsolved so that we can solve it in the future. But that's gonna be a wrap for today.